Okay, good morning, everybody. Or I guess it's almost afternoon. The day has just gone so quickly. We are entering our last session of day one for Ready STEM Go. We started out bumpy this morning. We had those issues with our keynote, but we're going strong now. Hopefully, you have found some great resources and are feeling inspired to kick off some summer STEM learning. It is my pleasure to introduce our speaker for this session. Sorry. This is Stephanie Batres Spezza, sorry. Hopefully I am pronouncing that correctly. She is from SparkShop here in my hometown of Chicago, and Stephanie is the program manager, and she is also a very experienced science educator. Today, Stephanie in this session is going to really highlight engineering and the engineering design process, but also how that can, when paired with hands-on learning, can really highlight and support personal growth and development and social emotional learning among the youth that are participating. People don't always think about engineering and social emotional learning, but they really do support each other. And Stephanie's here to tell us all about that today. So I will let you take it away.
Yes. Hello, everyone. Good afternoon. It's so great to be with everyone. Again, the session is on social emotional learning in STEM. And thank you so much, Kim, for that introduction. A little bit more about me. Um, I'm bringing in over 10 years of experience as both a middle school educator as well as a teacher educator, which has really grounded my commitment to student-centered and justice-oriented science education. Currently, I'm pursuing my PhD in science education at the University of Illinois, Chicago, where my research focuses on the intersections of identity, power, and interdisciplinary approaches in STEM spaces. My role, I was a program manager, but as of Monday, the recent promotion, I am the director of programs here at SparkShop, where I oversee everything from the development to the implementation of our programs and partnerships that support equitable STEM learning experiences for young people here. And at the core of my work, I would say, is really a passion for transforming STEM educations to really ensure that it not only builds knowledge and skills, but it also is honoring our students' identities and lived experiences and invites them to really see STEM as a space where they belong and feel like they could be making an impact. And a little bit about our organization. SparkShop is a STEM nonprofit organization. We really aim to inspire the next generation of engineers by providing free STEM education for elementary students in predominantly under-resourced schools. We really hope to empower students to see their value in STEM fields because we really believe that the industry needs a larger, more diverse pool of technical talent. SparkShop was founded in 2017 by two engineers who wanted to bring STEM experiences into elementary schools across Chicago. They were really motivated to enter the STEM education world after experiencing themselves how non-diverse the manufacturing world was and how much that impacted their own role as engineers. Our core program is a fully prepared STEM curriculum for fourth and fifth graders that we deliver to schools, again, absolutely free. And last year, we've expanded our programs a bit to older students through some alumni efforts, as well as a middle school design challenge. And we also host a summer internship for high school students. And so I would love to get a sense of who is in the room. And so if you don't mind in the chat, just putting in your first name, your role, and then taking a look at the tree. What number to you describes how you're feeling today? And correct me if I'm wrong, Kim, the chat is available, right?
Yes, chat is open to everyone.
Okay, awesome. Thank you. So I'll give everyone a second to do that. I love this picture. I feel like because you were defining it for yourself too, what these individual pieces or these individual little blob folks are, but um, so I definitely can see the range here. I see a few 15s. But I love to start with this just as a great kind of check-in for ourselves, but also to kind of honor where everyone is coming in today. It is May 7th. So I know for the folks that are, more closer to the grounds at schools, kind of winding down the year, I'm sure is a lot. Um, oh, the 10 and 11, yes. Yes, yes. Personally, I feel like a 15 in the way that I'm interpreting it. Yeah, I have a 5-month-old who is still learning how to, as I put it, kind of learning how to sleep through the night. So that has like me holding on to the tree. And but at the same time, really happy to be here. So definitely holding on, but yeah, happy to be here. Thank you, everyone. Thank you for participating in the chat. It's great to check in with everyone and seeing such a range of folks too from different specialties, different areas. Awesome. So moving forward, before we dive in, I want to take a moment to kind of ground us in a few norms for our session that will really help guide our time together. First, I invite you to prioritize being fully present, whatever that looks like for you today. I know that time and energy, our energies are definitely very limited, so I'm very grateful that you are here with us together in this learning space. I also want to acknowledge that we can create the space for multiple voices. And this really means listening to understand, not necessarily just to respond. Your perspectives and experiences are valuable, so I want to make sure we're holding space for those throughout our session. I also want to honor the different ways of processing and problem solving. Some folks like to jump in right away with ideas, others like to reflect quietly before sharing, and both are welcomed and needed. And then we'll also be offering some pauses throughout for some participation through the chat. So feel free to engage there if that's more comfortable for you, or there are moments where you feel like you would like to unmute instead. And finally, we'll reserve some time at the end for some questions. But if something is urgent or unclear that comes up along the way, please feel free to drop it in the chat and we can definitely provide some space to address it. The so jumping into the session, we're going to be exploring how STEM lessons can intentionally be designed to support social and emotional learning goals. To guide us, I'll be using the design thinking process as our framework. And this process really lends itself to both STEM and SEL, as it centers empathy, collaboration, iteration, and creative problem solving. And so what we'll do in the session is really take a look at how each one of these steps in the design process we can be introduced to how that content can really respond to our students to look at real world examples of how they're seeing engineering practice and how they are practicing those SEL skills in meaningful, integrated ways with, of course, their STEM learning. And so, as I said, we'll move through each step with a balance of content, examples from the field, and practices that you could be bringing into your own spaces as well. And so by the end, you'll leave with some concrete tools and ideas of how to bring SEL and STEM together in your teaching in your spaces. So first, I want to start off with the definition of social emotional learning. So taking a look at this definition, SEL is the process through which all young people and adults acquire and apply knowledge, skills, attitudes to develop healthy identities, manage emotions, and achieve personal and collective goals, feel and show empathy for others, establish and maintain supportive relationships, and make responsible and caring decisions. If you notice, there are phrases here that really mirror the practices that we're encouraging in STEM activities, such as achieving goals, empathy for others, responsible decision making. And so SEL skills really empower students to be better technical problem solvers. And STEM skills help support students working through these SEL challenges. So when we're thinking about the why behind combining SEL and STEM, What we know is that the next generation of engineers, scientists, problem solvers, they're going to be facing some really complex and interconnected challenges, things such as climate change, public health crises, ethical, technical developments, right, and more. And to really be able to navigate those challenges, we know that technical knowledge is not going to be enough. They really are going to need a strong social emotional skills, things like empathy, communication, resilience, collaboration, in order to work across disciplines and really understand diverse perspectives to create solutions. So what's powerful is that STEM learning is already giving us a natural space to really nurture those skills. So when we engage with students in STEM, they're already practicing things like teamwork and creative thinking, navigating failure. And so instead of treating SEL and STEM as separate, we can really be intentional about designing opportunities for students to really think about STEM learning simultaneously to developing their social emotional capacity as well. And that's the work that we're going to be digging into today. Starting with empathy. So when we begin in the design thinking process, we begin with empathizing. This step is about understanding the people we're designing for. And at this stage, we're identifying things such as pain points, opportunities for improvement by really tuning into others' experiences, needs, and emotions. And we do this by asking thoughtful questions that go beyond just that surface level to get at really how are people feeling? What do they value? What are those challenges that people are facing? And when we empathize, we're observing with intention, we're noticing behaviors, interactions, environments to really uncover the insights that may not all be so obvious. And so from an STEM and SEL perspective, this is a really powerful entry point for developing skills like empathy, curiosity, and perspective taking. And in the classroom, we really hope we could support students in building these skills by encouraging them to slow down, listen actively, and reflect on what they've learned about others. And to give us a little bit of a case study here, bringing empathizing to life, I want to share a case study from IDEO, which is a design and innovation firm. They're known for their human-centered approach. In this example, IDEO researchers, they were looking for a ways to really improve the design of like pill bottles. And in this particular study, they focused on older adults who were experiencing some mobility issues, things such as arthritis. And during an interview that they were conducting, a woman shared that she had no issues with her pill bottles and that she felt like they were working just fine. However, IDEO's researchers, who are known for conducting really thoughtful, open-ended interviews, they asked her to show them how she was using those bottles. And so she went into their kitchen and actually pulled out a meat slicer and sliced the top clean off the pill bottle. And that was how she was accessing her pill bottle. That moment revealed something really important. It's that people often work around pain points. I'm sure those of us as educators know that, right? We often work around pain points and sometimes may not even identify them as problems unless we take the time to observe and dig deeper. This woman had found a solution that worked for her, but it also revealed that the current design was clearly not meeting her needs. I think this is a really great example of how empathizing kind of needs to go beyond what is said. It means being curious, it means asking good questions, and watching for actions that tell us a little bit more than just words could possibly do. And so empathizing in the classroom, some practical ways that we could be practicing these skills. First, we can one way we can do this is like acting out a classroom routine, things such as like unpacking a backpack, lining up, using the water fountain, and asking students to identify potential pain points, right? Like doing that process and then asking like, what is feeling awkward about this? What do you think could be improved? And this helps them to kind of practice that noticing things that might go unseen otherwise, right? Like regular routine things that just seem like the everyday, but really, if they unpack it a little bit more, could identify some potential pain points. A second is having students practice interviewing. from our teachers, they notice as they're practicing these interviewing skills, they definitely notice a difference from the fall to the spring in the students' ability to really gather insights from that other person, right? At first, it might just be surface level questions, whereas then with practice, they're really getting deeper and asking more follow-up questions. They could do things such as asking about a small challenge, like how do they organize their school supplies or how do they get ready in the morning? So very, universal questions, but they could be gathering some of those pain points and then sharing out what they learn. Doing this type of practice is really building their skills for active listening and compassionate questioning as well. Another way too is really just integrating it to what we're already doing in the classrooms, where we can integrate it into literacy. We can have students identify pain points in the stories that we're reading, whether it's pain points that a fictional character is experiencing or someone in a non-fictional article. Students can really explore this idea of like, well, what challenges is that person facing, and how might their experience help us design a better solution? So as educators, we're always working with a variety of pain points. I'd like to ask you to, in a moment in the chat, when it comes to integrating a new STEM activity, what are some of your pain points? I'll drop that question in the chat so that you can see it as well. I know for me, it was a lot of it had to do with time. Time was always a pain point. Yes, materials. And being thoughtful about the materials to cost, how many, is it going to be in? Yes, logistic considerations for materials too. There's a lot to just like, it's not just materials, right? But it's everything that goes along with materials, from the ordering to like figuring out what is needed and to when do you give it to them so they're not distracted with the materials before like actually getting to the STEM activity. Things, the collection. Absolutely. Students leading the problem solving. Materials so they don't get used or destroyed ahead of time. Yes. Oh yes, glue sticks. That top, half of them would come back with tops. Somehow the markers would always just not have the right top color ones. You would think they have solutions for that already, right? Thank you so much for sharing those out. And so in our next step, this is where when we've learned we've taken what we've learned from that empathize phase, and we're really working to define what that exact problem is. The phrase "how might we" is really a sentence stem that students can use to really guide their own brainstorming. So we really want students to kind of craft really strong questions that set them up for success. Building a "how might we" question by Oh, it's a strength. Ah, well, I wasn't thinking it was a pain point. It was more so of like it does take a lot, right? It's not like from one day to the next, students are gonna know how to take the lead, but there's definitely a lot of scaffolding. So I can definitely take the scaffolding as like it's a lot of work on our teachers' end, right, to prepare and prep them for being able to do that. So, but wasting materials is absolutely a pain point too. Sorry, so heading back to the how might we question. Crafting a good question really helps them be set up for success. What we are hoping that they do is that they're building a how might we question by really synthesizing the information that they've gathered from empathizing. And again, really looking for the root causes of the pain points that they're noticing. So to give us an example here of a how might we question. Our traditional casts, they answered the question of like, how might we help broken bones heal properly? But if we look at this question, we have another company, Cast 21, that has recognized that there's actually tons of other pain points that could be addressed beyond just this how might we question. So although for thousands of years casts were fundamentally not improved, the founders of Cast 21, which is actually a Chicago startup, started to recognize that there are these other pain points that could be addressed. So things such as the cast is itchy, it's smelly, it's hard to shower with, right? It's always this like bag over and you have to shower, keeping it out. Um, it could be bulky as well. Hard, definitely hard. So they asked a new how might we question, which led them to developing a cast that works just as well and is an answer to that first question, but it's also offering a solution to that second of how might we help patients feel more comfortable while their bones heal. And so CAS 21 didn't just look at pain points, they also defined positive criteria and made sure that to keep all the little things that are good about CAS still around. So in their design, they were still thinking about, bright colors, and they were the other piece that kids love is to sign their cast too. So really also keeping those positive elements from the original design in their new design as well. And in the defining piece, we one way we could really be having our students do this is through some reverse engineering of how might we questions. It really encourages students to see that that there's technology that has emerged as answers to questions. It also shows that one how might we question can really spur tons of other different correct ones. Things like you could just pick up an object like a pen, for example, and thinking about this as the final product, they can reverse engineer and think about like what questions do you think that this pen was answering, or what pain points do you think it was addressing? And when we have students practice creating these how might we questions, we really have this uh, hopefully goal of them seeing the Goldilocks rule. Sometimes we purposely have them write 3 questions, one that's too broad, one that's too specific, and then one that's just right. And we find that having them do this practice of the Goldilocks rule helps them to kind of play with the what it's not to really get that at an example of what it could actually be. And to move towards ideating the next stage in the design thinking process, we know this is the part of the design thinking process where they're brainstorming as many possible solutions as they can, and the goal here really is quantity over perfection. The more ideas, the even better, even if they might seem wild or unrealistic at first. To do this, which I know is very hard for not only adults, but for students, is to really silence that inner critic, that voice that's like when you have an idea that's telling you, no, that's a bad idea, or no, that won't work, right? And so then that really pauses and delays that ability to provide more ideas. And we really want to silence that inner critic. We encourage students kind of embrace the silliness, because sometimes the most out there ideas lead to the most unexpected breakthroughs. It really can actually spark a new line of thinking that gets us to a strong solution. And so just like in the engineering field, this is best done in teams. Collaborative ideation really helps build off of one another's thinking, really allows folks to see things from different angles and really push our creativity further versus us just having to do it individually. So in this stage, the focus really is to be bold, being open, but also having fun while being imaginative in all the possible ways that this problem could be addressed um, in their answer. And so give us an example from the field. Here we have the 1956 Dodge La Femme. I don't know if anyone has seen this example before, but it's a car designed for women by a team of men. And so in this example, what we're seeing is that the La Femme was available in pink. It came with a matching purse and makeup. And can you imagine why it was a failure? I wonder why. But really, it's that there were no pain points addressed here. The design team, unfortunately, was informed by stereotypes rather than the actual user's needs and pain points. Yes. And there was, we can see there's an apparent disconnect and a mix of just kind of adding on things that people didn't want, versus really addressing the true needs of a driver. Um, going back to really empathizing and bringing that piece to all these different steps. And so some ways we can be practicing ideating with our students. One is that they could be doing a personal inventory activity. Really helps kids to identify the ways in which their perspectives might be similar or different from their teammates. It also really brings to light that like diverse teams make for better designs. So we want to encourage them to ideate with students whose inventories look different than them, for them to really reflect on like what knowledges and identities am I bringing to my brainstorming team. There's also the antonym game, which is a nice quick way of practicing ideation, where you could write a word on the board, for example, or on a smartboard, and encourage students to name as many antonyms as possible. When we hear the word sad, the first antonym that comes to mind might be happy, but we can continue to build on those answers, and then maybe even hearing other people's answers, we can kind of generate more. Feel free if anyone has any examples of antonyms to throw in the chat. Antonyms to sad. Mm, that strong start. Yes. Elated joys. And as a teacher, could be recording all the different answers as they're going through. And satisfied, overjoyed, energized, excited, interested, exuberant. And after the antonym game, there could be some time set aside to really reflect with the students on how did it feel to do this sort of brainstorm, and really calling attention to the moments where it felt like they were out of ideas. I don't know about you, but sometimes I get to that point where I'm like, I just can't, there's nothing else I can pull out. And then someone else adds something else, and that reopens then that conversation. I think we kind of saw a little bit of that in the chat of like some spurts of answers, pauses, spurts of answers. And to deepen this activity, you can also brainstorm. You can have students brainstorm on pieces of paper first, and then pass those papers around. And after a minute, this is their way of kind of adding on to other people's answers and ideating on that first idea. And again, reflecting on the process is also a really important idea as well, because they're noticing what was helpful in the collaboration piece to keep that going, but also what did they need from themselves to really generate these ideas. In the next step of the design thinking process, we're looking at prototypes, prototyping, and prototypes are for not only learning, but they're also a great tool for communication. And so when building a physical model, there's usually hundreds of tiny decisions about what and how your product should look and how it should work. And it's really important that when it comes to prototypes that we're striving for a rough model and not perfection. And we can think of there being kind of two different types of prototypes that you see here. One is for something that looks like the functional model. So up on the top, we're seeing what it would be, what would that app look like? Or a functional model like the Oculus there that's taped around with a Xbox remote. And this is more of like a works like. So really giving a feel for what that experience would be as a functioning prototype versus definitely not an aesthetic one. And so students can really use either aesthetic or functional prototypes to communicate their invention ideas to other people. And in prototyping, the goal really is to build a model that communicates ideas to others, really allowing you to get feedback. And at this stage, it's extremely important to understand the audience and their goals. For example, in this case study, we have IBM who had a rough prototype of early voice-to-text software, and it needed to determine if it was valuable enough to customers to really continue that development. Because before you dive in and invest so much money into something, is it something worth pursuing and collaborating and investing a lot of resources on? So this in this case, we're not even thinking about like a physical prototype, but something that this I think really illustrates well is that these engineers at IBM in the 90s were developing a voice to text transcription software. So the software model wasn't perfect just yet, that what they were developing, but executives wanted to test a prototype to see if this idea was really even something people were willing to pay for. You imagine that, paying for it. In their prototype tests, IBM had users speak out loud and then see their words appear on a screen in front of them. And then they were interviewed on the utility of the idea. Like, did they find that to be something that it would be worth purchasing? And the twist in this story is that the prototype um, was actually real humans just typing out the words as they were spoken, but presented as if it was the computer doing it. And what this really represented is the value to that final idea is better at a much lower cost savings prototype, really just doing something to gather that feedback needed at the time. And then, we see that IBM was confident that their engineers could build this working model if as the final product, but they knew that at this stage they shouldn't really invest all those resources to doing it yet. Um, yeah, Kevin, absolutely. Intentionally blowing like and failing in front of the kids too, right? Is it kind of shows us as human beings that like we as teachers, we're not always going to get it right, and really showing that humanity piece on us, but also for them to understand that failure is just a natural element piece of that everyone goes through, and it's definitely just a learning experience. Some ways that we could be practicing prototyping practices with students. There's a couple quick examples that you see here of how to incorporate them. For example, you could be using 3D Pictionary, things such as using Pictionary prompts to really challenge students to build quick 3D models in either Play-Doh or clay. And the key here is that it's quick, because I'm sure if we gave them so much time, they would love to perfect it and spend as much time as possible in creating it just right. But I think one of the other challenges is to like let go of it not being perfect and being okay with that too. So I think it's the practice at that too, is being okay with not non-perfection. And another is like I Spy prototypes. So challenge students to build a model of something in the room. So the I Spy, if you have a 3D printer in the room, for example, and they could be prototyping an example of what that looks like, and building it and having their peers recognize what it is. Both activities are really encouraging students to build for clarity and communication. And again, the goal here is not for perfection. It really is for them to understand that prototypes are for communicating. And I know sometimes that could be so hard when our students are trying so hard to get it just right. And then the next phase, we have testing. Oh, sorry, Tracy. Yes, the learning is always in the mistakes. The only failures are not trying. Yes, absolutely. Yes, right. Giving up before even trying. Um, in this phase of testing, testing is a process of figuring out if we did a good enough job of solving that how might we question. Testing is often the most challenging section, because with the most innovative products, you're often designing your own custom tests. You're revisiting that criterion constraints and designing tests to really ensure that that design is meeting what you designed it for. But from an SEL standpoint, this is the hardest step because this is where we're going to encounter perfect introduction, which is we're going to encounter the most failure. We really must be ready to fail. And it's better, and the reality is it's better to fail in testing versus once this product is out in the world. I'm sure we can all attest to different products that we've bought from the store, and it has completely failed. Recently I bought a hair dryer. I plugged it in. and it did not turn on. And I was like, how is this even possible? Thankfully exchanging it, but you would think that like what are the things that are, oh, and mind you, I looked up the reviews and apparently this was common for that hair dryer. Um, but you would think that these kind of kinks in the design would be addressed previous to that, right? And that's really the goal here, is it really should be at the testing phase with your prototypes, versus once things are kind of just out and mass produced and so much time and resources have been put in to them. Here in this example of the pictures, we have 6 battle bots. They're all designed for the same competition. They're actually all answering the same how might we question, but doing it in different ways, as you may notice. The designers of these battle bots, they have prioritized different criteria. So some have prioritize durability or some steadiness, speed, turning radius, and other things. So therefore, they've probably conducted a variety of tests that have led them to that specific design. Um, Kim, yes, too many times have fallen for a product on TikTok that does not really work. Absolutely. Yes, I agree that you can absolutely see like that aesthetic piece, right? Because why else put eyes on a on a battle bot? Maybe to make it more intimidating. Maybe that was their criteria as well. Um, but yes, absolutely. I think we can note some of those this design decisions too, even within color, end game, as the name of their battle bot too. Um, and yes, Kim, I completely agree with that. I feel like there's way too many of those where I feel like I'm bamboozled by I was like, it clearly looked like it was working. But probably I don't know. I don't know what kind of sham they're able to pull off and make things look like they work. And so thinking about a case study here. I'm sure we maybe have heard headlines here around like facial recognition, but there is some new promising facial recognition software that was brought over from Norway as part of the exhibit at the Griffin Museum of Science and Industry. But when the staff started testing it, it didn't perform as well as it had originally in Norway. Can you guess why? Why a facial recognition software in Norway wasn't working here in Chicago? Any guesses? In the chat or unmuting, of course. Yes. Yes, thank you. Tracy, yes. You're right. That would be one of my guesses. They're smiling in their facial recognition.
Not as many reasons to be grumpy.
Yes. Uh, um, I would think that too. But and yes, what the other drops in the chat also alluded to is that yes, when the software was tested in Norway, it was trained on a team of researchers, most of which were white men. And the team at MSI was much more diverse, and in that environment, that software failed. So the failure really echoes what we've talked about at the ideating phase about making sure that the team that we're working with, like when we were talking about the inventory piece, that the team that we're working with is not sharing the same blind spots that we may have in the design thinking process. So again, really getting to why it's so important that we have a diversity in so many aspects. Whether that's our backgrounds, or the ways of thinking, our specialties, our ethnic, racial demographics, all of those pieces are ways that diversity is important to bring in at all aspects of our design thinking process. And so some ways we could be bringing this into our classrooms. A huge part of testing involves getting feedback from others, people like potential users, other designers, experts, and giving and receiving feedback I'm sure we can all think the same, that it's an art. It's not always the easiest. So sometimes setting up our students, feed work is hard for grown-ups. It's also it's also difficult for students. And so giving them some frameworks, for example, of like, I like, I wish, I wonder, as like sentence prompts, really guide students into practicing how to provide that feedback, where students can finish each sentence and offer a compliment, something that they wish was different, or a question that they still have. Our role is really to help students offer feedback that is kind and constructive. I don't know about you, but like I've definitely experienced both, right? Maybe feedback that is just kind or feedback that is just constructive. And I'll say that having both of those without the other feels incomplete. Um, and so we really want to help students be able to provide that feedback, but also to receive that feedback with an open mind, which of course really only happens with practice. We can't just say like you're going to be good at it from the get-go. It is absolutely a skill that happens just with more practice. So we can really think or help students think about testing as one of those ways of receiving feedback. And so to help support students through this testing phase, we can help brainstorm some tests based on some prompts, and let them know that like not all experiments can be conducted in a classroom, for example, but maybe there's still some value into thinking about what that design could be. So for example, like maybe it's just a warm up instead of like something you actually do. But it is something for them to think about. Like, how would you test the durability of a Chromebook? Yeah, we don't want them to necessarily maybe take a sledgehammer to a Chromebook in the classroom, but I think thinking through that question is still really valuable because they have to think about um, what technical piece is required to actually understand if something is durable, or how could you test the style of a new kind of shoe. So maybe thinking there about receiving feedback from others, or really how do you test what's stylish, and even bringing that as a conversation within the classroom as well. And so I think what is beautiful about the design thinking framework is that, as you notice here in the center, is that iteration is key. Iteration lives in the middle of the design thinking framework because it's really happening at any of those steps. We really may encounter failure at any of those steps, as well as gaining new information. You know, I think back to when you are empathizing and learning more about the pain points, and you come to define that problem, maybe you've ideated. And once you've ideated some brainstorming solutions, maybe you brought it back to that original user and gotten some feedback. And maybe your brainstorms, those ideas don't necessarily reflect those original pain points. That's where iteration comes in. And maybe we have to kind of broaden out and think more about what questions should I be asking now in that empathize piece. So it really helps us to understand that going back, thank you, Kim. Going back to each one of these steps, it doesn't mean that it's a failure, but it really is an opportunity to get our ideas better. When we iterate, or allowing ourselves to really adapt to the new information, which in and of itself is a skill. And it only helps us grow and create better solutions if we allow that to be a possibility in our design thinking process in our STEM activities. And so here we have an example of like Post-its. Post-its came from a failed adhesive project. Engineers were trying, in this case, to create a product, but they really failed to create a paper that could get stuck to the wall. Like that's what they wanted. But upon iterating, they actually realized that maybe they have a different how might we question. Maybe the question isn't how to get it permanently stuck, but maybe how can we, or how might we temporarily stick notes to surfaces without damaging the walls? So a failure really turning into a success. There's also Kevlar was a similar invention. So the chemical engineer that invented Kevlar, they originally were looking for a fiber that they could add to tires to allow them to last longer. And that fiber she made was too long and too tough, and it really actually it ended up reducing the grip of the tires. So it didn't work in that aspect. But what she did realize is that the fibers could be woven into a very strong material. And so what was then noticed is that that strong material could be resistant to things such as knife edges. So like this would be great in gloves, for example. And so that's actually how Kevlar was created, out of a failure that then led to a success. Oh, sorry. And so practices here, we really want to remove feelings of dread from the word failure with our students. Not every failure will end up like Post-it notes or Kevlar, but that doesn't make it any less valuable. And I really want to emphasize that iteration is a great opportunity to build comfort with failure. The standard that I've called out here, down here on the bottom, can be really applied to get students to talking about how does it feel to move backwards in the process. Acknowledge that their first idea wasn't necessarily their best idea. And here are some opportunities to really name the feelings that they're experiencing as they're iterating, but also to create some routines that really celebrate this iteration and making failure actually feel exciting, which I know there's a great piece on that in the Rosie Revere Engineer children's book that has a very impactful example of and bringing in the emotions that are felt through iteration. And so to wrap our session up here, some key takeaways are that, social emotional skills really help engineers and inventors of all ages really apply that design thinking process. They're really both necessary. We see that STEM classes provide unique opportunities to really practice these SEL skills. And we could really lean on things like games, hands-on activities, storytelling to weave these key topics together. If you notice, all those different examples were ways where it wasn't necessarily a right or wrong answer, but more so playful ways that we could be practicing these skills within our classrooms. And of course, if beyond this session, if there's any other lingering thoughts or questions, I have my email, Eileen as well, who is our impact manager, would also be happy to respond. So I'll leave some space for some questions, but of course, I know that we're all different at processing and our processing time. So I also acknowledge that as well. So thank you, everyone. Thank you for your participation.
Stephanie, thank you. So many good ideas there. I think it was wonderful. I could not live without Post-its. So thank God they made that mistake. But yeah, as we wrap up, anyone have any questions they would like to ask Stephanie about? We all know the importance of engineering, so any?
And I've dropped my email again in the chat, and in case that if anyone would prefer to just do it offline too.
Perfect.
Does your programming specifically start at school age?
Yes, it is meant to be run in schools in 4th and 5th grade.
Oh, at 4th and 5th grade. So I'm an early childhood person, and we start with STEM in toddler classrooms. And so I think that there is an entire curriculum there. I will reach out to you because I think a lot of school districts have pre-K now. And so thinking that they have to wait to start talking about STEM is, we're losing years there. So making Play-Doh is STEM. Playing with slime, all the sensory, and it all ties to the social emotional.
Yes.
So yeah, I would love to talk to you. I'm in the Chicago area also.
Oh,
so great session.
Yes, and I realized I did not drop my chat in everyone's, so I apologize in the chat. I'll do that. And yes, thank you, Tracy. I absolutely agree. It is definitely something that needs to be explored with even younger students as well. I mean, because there's already an innate love of discovery with our younger students, and so it's absolutely already happening in their brains in the ways that they're processing and learning about the world.
Well,
Yeah.
and 5-month-olds explore with their hands and their mouth and their feet.
Right.
So, usually food is their first sensory experience, but then you're building vocabulary with slimy, squishy, sweet, sour. So enjoy that baby and, start now.
Yes, yes.
So I'll reach out. I'll be emailing you.
Yes, thank you, Tracy.
Great session. Thank you.
Thank you.
This is awesome. And I agree with the preschool and STEM. In Ohio, we did an 8-month peer learning community with 6 preschool programs, helping the teachers feel more comfortable with their facilitation skills when leading STEM activities in the early years. And today I still get emails from some of the directors like, oh my gosh, and pictures, just how much more confident their staff are leading STEM activities. And like you said, Tracy, they're doing STEM. The teachers just have to be a little more intentional with what they're doing when they're planning the activities. So,
Well, and not
yay
only
for early
that,
childhood STEM.
I do a workshop called Buzzword Bingo because our early childhood teachers and our first and second graders are doing STEM and don't realize how to
Yes,
explain it. So I
yes.
play interpreter. When you put that Hot Wheels car down the paper towel tube and it goes faster when you raise it, that's
Mhm.
physics. You're
That's
doing
right,
physics with 3-year-olds.
right.
And they're like, I am. I I don't know how to explain it. So part of it is helping our early childhood and younger grade teachers understand that what they're doing is science,
Right,
is doing engineering. Block
right.
play is STEM.
That's right.
That is such an important point, right? I mean, and it's fun. So they're answering their own questions in a very authentic way. So the more exploration, the better.
Yeah. Have a great day, all.
Thank
Thank
you. Well,
you.
thank you everyone for your time today. Hope you had a fantastic morning or early afternoon. And I know everyone's heading out to, some people are heading out to programming, some people are heading back to the classroom. Hope to see you all back here tomorrow. Really, really good sessions. We will be starting bright and early. Keep in mind, tomorrow's sessions are 90 minutes long, so you can really dig deep into some topics. So explore the lobby and make your schedule for tomorrow. All right.
Yay.
Great. Have a good day, everybody.
Thank you. Bye-bye.
Bye.